Let me say something controversial. Some of the cleanest code I have ever seen was also the least useful code in production. And if you have ever joined a project where the code was beautiful but changing one line broke 5 services, this video is for you. By the end of this video, you'll understand why clean code often fails in the real world system, how it tricks smart developers, and what you should actually optimize for if you want to survive real world software, not just pass code reviews. And no, this is not a clean code is bad rant. This is about clean code in the wrong context. So here's the problem. Most of us learned clean code from books, courses, or tech Twitter. Small examples, perfect scenarios, no deadlines, no legacy system, and definitely no production incidents at 2 a.m. Real systems don't work like that. Clean code usually promises 3 things. 1 is readability, 2 is maintainability, and 3 is fewer bugs. Sounds amazing, right? So why do so many clean code bases become slow to change, fragile, and impossible to reason about? Let's talk about the first reason why the clean code fails. Clean code is amazing at solving local problems. Open a file, short methods, perfect names, no duplications. But real systems don't fail locally, they fail at the boundaries. Between services, between teams, between assumptions that were made 6 months apart. Clean code makes files beautiful. Real systems needs flows to be understandable. And this leads to the second most dangerous thing clean code encourages. Abstractions. Clean code teaches us extract this, hide that, depend on abstractions. So we do. And now the simple request flow becomes a mess of calls. Controller calls service, service calls manager, manager calls handler, strategy, adapter, factory, and then implementation. Each piece is clean, each file is readable, but no human can hold the whole behavior in their head. Clean code is optimized for reading files. Real systems requires understanding the behavior rather than the files. And here's the part that nobody warns you about. Clean code can make changes more expensive. In real world systems, requirements change constantly. When you over abstract, a small change touches 8 interfaces, 5 implementations, and 3 tests that don't even describe the real behavior. So the system becomes correct, elegant, but at the same time, painfully slow to evolve. Businesses don't fail because code is ugly. They fail because the change can't be done fast enough. So what's the solution? Should we just write ugly, hacky code? No, but we need to redefine what clean actually means. In real systems, clean code means clear data flow, obvious side effects, fewer layers, and boring, predictable patterns. Sometimes a longer method is better than 5 abstractions. Sometimes duplication is cheaper than indirection. Sometimes the cleanest code is the code that a new developer can understand in under 10 minutes. Here's the real truth. Clean code is not about how the code looks. It's about how safely it can change. If your system breaks easily, surprise developers, or requires tribal knowledge, it doesn't matter how clean the files really are. Clean code doesn't fail because it's wrong. It fails because it's often taught without context. Real systems reward clarity over cleverness, stability over purity, and evolution over elegance. Write code for the systems you actually have, not the ones that you read in the books. If this helped you see clean code differently, hit like, subscribe, and tell me in the comments, what's the cleanest code base you ever struggled with? I'm Codey-Singh signing off. See you in the next one.